Hi, I'm Kristen Bell, and if you know my husband Dax, then you also know he loves shopping for a car. Selling a car? Not so much.
We're really doing this, huh?
Thankfully, Carvana makes it easy. Answer a few questions, put in your VIN or license, and done. We sold ours in minutes this morning, and they'll come pick it up and pay us this afternoon.
Bye-bye, truckie.
Of course, we kept the favorite.
Hello, other truckie.
Sell your car with Carvana today. Terms and conditions apply.
Lowe's knows how to help make your home holiday ready for less. Get Select Style Selections vinyl flooring for just $1.99 per square foot and have it installed before the festivities begin. Our team can help you every step of the way. See a Lowe's Red Vest associate or visit Lowe's.com/holiday install to get started. Lowe's, we help, you save. Basic install only. Date restrictions apply. Subject to availability. Installed by independent contractors. See associate for details. Contiguous U.S. only.
Today's episode is all about visual thinking and learning. We will expand on an underrated, nearly unrecognized power of the autistic phenotype, visual thinking. Not just seeing a picture, but the vivid details, the movies, acuity, experiences, etc. This fascinating phenomenon does for learning. With that, we will discuss associative learning and procedural learning, and a theory called weak central coherence by Happ and Frith. It's about 25 years old now. Very fascinating and relevant. We will explore and expand on what Leo Kanner and Hans Asperger highlighted. More recently, Temple Grandin provides wonderful experiences and scientific exploration of visual thinking. The autistic brain sees details, then it spans out to see the bigger picture. Remember the anecdotal example in the first episode of visual thinking about the trees, seeing the trees. But I could only see the tree bark, the different types of bark. It builds models. The autistic brain builds models, and it's detailed and precise models of the world. In other words, the autistic brain and the autistic phenotype uses a similar approach to machine learning and AI. Remember Hans Asperger's first paper in 1944. Much of the lengthy paper, was on autistic intelligence. Remember Asperger's little professors. He nicknamed those kids little professors. Remember the 11 case studies from Leo Kanner in 1943. Similar learning style and imagination. Remember the translation of autism comes from autos, which means self. Remember the early origins and connections to schizophrenia, the visual hallucinations. Intense dreamlike states is exactly why autism was used by Eugene Bleuler. And for the record, it took me 5 takes to say that last name. And I don't even know if I got it right. Remember Piaget highlighted this a little in the 1920s, with selective kids appearing to have intense interworlds. Most importantly, remember these crucial mentions shared from the start of the podcast. The origin of the podcast are things like this. The biology that gives us autism allows us to be comfortable within ourselves. And that accelerates learning. And remember B3, restricted, fixated interests that are abnormal in intensity or focus. How is that a thing? Remember, social norms are in contrast to the autistic phenotype, especially in education. The outside world is a conundrum, an odd paradox, and humans fit everyone into a box. so they can evaluate and predict. And this is an answer key. The entry point, the path, this gate that must be entered, etc., into learning is not an easy entrance. For the autistic phenotype, that is not so much the case. Humans can complicate themselves so easily. We can spend an infinite amount of time and create these distractions, these reasons that prevents themselves from exploring outside the box. Humans construct a box. Inside this box is everything they know, everything we know. And humans want others to fit inside of a facade construction to evaluate and for prediction. If you can fit someone in that box, or even manipulate them into your perception to make the others fit inside that box, it's acceptance. If not, it's rejection. In other words, if you can fit something inside of this quick answer key, this quick box, you accept it. It's easier for you. If it's not inside the box, if it's different, it's outside the box, you reject it. Humans love this because it makes it easier on the observer. And you don't like that when others are outside that box you've created. It's complicated and hard to make sense of when this is occurring. You don't like that. You hate those underlying feelings that are offending your beliefs, offending your abilities to understand. You might even resist that. Let's get into this. How autistics build catalogs in different categories. A remarkable similarity between autistic brains and artificial intelligence and that machine learning is forming concepts by collecting and organizing specific, concrete examples. And this is often visual image, sensory experiences. And this is collected and they form a mental database or like a library. So, for instance, the catalogs. Unlike neurotypical individuals who might rely on the abstraction or generalization ideas, autistic people, especially those visual thinkers and the ones that see the movies, construct categories by compiling these detailed instances, these examples. And Temple Grandin, in Thinking in Pictures and the Autistic Brain books, describes this in quite detail. She explains that her mind works like a search engine for photographs, and she sorts these specific images into categories to understand the world. An example she gives is a butterfly. Grandin doesn't think of a generic butterfly. She often talks about churches and the steeples. Maybe she sees the type of block or brick. She sees real life examples, things that she's encountered and seen. And she's building this up in this mental model. For instance, with the butterfly, she will see specific butterflies, one from her childhood backyard, or a metal decorative butterfly, a painted butterfly, and so on. Each image is in a file that's kind of labeled the mental catalog. This is like the filing system I explained in the previous episode. And this is our collection of, okay, that's what a butterfly is. When Grandin calls this associative learning, and this is a hallmark of how many autistic individuals build these catalogs. It's a bottom-up approach, starting with specific details, and then gradually constructing broader concepts or ideas or images. And this is the weak Central Coherence Theory by Happ and Frith from 2006. They have studies from 25 years ago. It's essentially a cognitive processing style in autism characterized by preference for local or detailed-oriented processing over the larger, global, contextual integration. They suggest that autistics excel at focusing on specific elements of information, such as noticing minute details in a visual scene or memorizing precise facts. But they may find it hard and challenging to synthesize these details into broader, holistic understandings of the world. This weak central coherence is very powerful in perception and learning and this categorization. There is something called embedded figures test, and autistics show quickly they identify a hidden shape within a complex image because of the focus on the individual components rather than the distracting whole. Just instead of viewing the whole, scanning the whole picture. This is a strength of the visual processing, which allows acceleration in activities requiring precision, such as spotting differences in images or analyzing intricate patterns in art or design. This is very AI-ish. And I can't underestimate this enough, and I can't convey this to you enough. The delays in the sensory processing because of this, and then the implications to socialness. Do you understand this? This visual thinking style enhances our ability to notice subtle details, however, can make tasks requiring contextual understanding, like interpreting social situations, understanding of each other and what social cues are, very challenging. Remember previous data that we've discussed about local processing and the sensory processing being kind of heightened. This is what's happening here as well. This is just another way of explaining it, understanding it. This local processing kind of biases an ability to focus on discrete features of objects or concepts, and that accelerates the learning. That spending that heightened awareness on this specific detail strengthens the memory here. And you should be thinking about the pattern recognition as well, and then just how autistics can see patterns very well. I will give you an anecdote about how I associate things, especially with people. I've done this for as long as I can remember, and whenever I was younger with different peer groups, they would disagree with me, but they missed what I was saying. I would compare people, new people even, with certain phenotypes about them to somebody else, especially famous people. And I would pick out these fine details about this person. Maybe it was some sort of phenotype, but it was very covert detail that I could see from this other person, and then pull it up in this other kind of model or this category that I knew about this other famous person. And this was very fine detail. Maybe it was a jawline or the way that their chin looked or was shaped, the distance of their eyes. It's this sort of kind of fine detail phenotype that I could see, pick out from the other person, and then compare it to this famous person or from somebody else. Maybe they're not even famous. And I would do this with maybe some sort of nuanced behavior that they have. Maybe it was their pace of walk or their step or the way that their shoulders would slouch or the angle of their thumbs. Have you ever noticed that the angle of their thumbs as they're walking forward, or if they're just standing still, angles of the thumbs are different. Most modern humans, they're turned in almost like at a 45-degree angle. The thumbs should be pointed directly in line with your forward ambulation, the path that you're traveling on. But now, like modern humans, with this slouching and C-shaped shoulders, the thumbs are pointing in and they almost crisscross if you would draw an imaginary line out from the thumbs. Or other examples would be like a hairline or the size of their ears or something like this. Very fine detail and very quirky, hard to detect, very covert. And others, whenever I would mention this out loud, they wouldn't catch it because they're not looking like that. They're just looking at the general person, the overall person. I'm looking at stuff that's very precise, very pinpoint. And I would usually just say it out loud. That person looks like this person, or they have similar XYZ, whatever the phenotype that I was comparing and building up this model. This is exactly a good example of building models and different catalogs for different categories. And others would disagree with it. They would even make comments and laugh. It's like, no way. But they wouldn't see it. This same mechanism is exactly like the pattern recognition even. Seeing the little details first, and then zooming out, generalizing. This is exactly what AI is doing with when Temple Grandin gives the melanoma detection example with the autistic brain, machine learning, and AI. In addition, memorizing and organizing facts and information. This is very fascinating stuff here. This is very powerful. This is why words like the superpower is in the title for things like this. Not to be confused with the push-pull motivational tactics of society saying the autistic phenotype is superpowers. This is one of those examples. So with learning, this weak central coherence shaping the autistic individual's form and applying associations, particularly in this associative learning process. And we'll dive into that more deeply later. This is similar to classical and operant conditioning from old learning theorists and psychologists like Pavlov and Skinner. This explains why there's a strong association. This means that type of idea with autism. And you know, with the autistic phenotype, there's very rigid thinking. This is very black and white. There's no gray area because that strong connection, that strong associative learning to stimuli, this means that isn't flexible. Remember, we've talked about the medial prefrontal cortex in large detail and how it's kind of orchestrating adaptive responses. It provides us skill sets to use in the unpredictable world. We've covered this even the beginning of this episode. This is what complicates things. This is the kind of the downfall of this strong association, this accelerated learning. Remember the conversations about the salience network and the default mode network. Those two so-called networks are heavily involved here and strengthens the autistic phenotype. Other examples that you might be familiar with is like how autistics will categorize animals, maybe into fur types or habitats or big or small, number of legs, and so forth, colors maybe, how they purr or bark or the sounds that they make, the foods that they eat, predator or prey type of things here. And then there's just massive amounts of catalogs, inserting those pictures into each of these types of little categories about that specific animal. Similar to the tree bark. Instead of seeing a large tree, just a generic tree. Remember the tree bark example from the previous episode. I didn't even get to the canopy by the time I realized that others weren't doing this. And something fascinating about Temple Grandin is breaking the type of visual thinkers into different kind of subtypes. She so-called calls these object visualizers who think in concrete, detailed imaging, or spatial visualizers, thinks in patterns, or she uses the word abstractions here, that often excel in fields like math or music. Now, the word abstraction here is confusing to me. However, I'll just keep moving on. Object visualizers, like her, relies on cataloging the specific images to form these categories. The visual thinking is supported by unique neural wiring. She really highlights this in the autistic brain. It's very necessary reading if you want to understand the autistic brain. And in her brain, they found a large white fiber tract connecting her visual cortex to her frontal cortex. Remember these different types of fasciculus. These are called fasciculus. There's many. We have many different types, just depending on what they're trying to accomplish and the connections being made. The one that I can mention right now in real time is the arcuate fasciculus that connects Wernicke's and Broca's for the language and speech connection. What to take away here is this. Some of these connections are hyper-connected, like driving on an interstate. And some of these connections are hypo-connected. It's like driving on a gravel road. I don't think anybody can explain it any simpler and easier to understand form than that. Another worthy highlight from scientific literature is Matrone et al. In 2006, who kind of helped support this, showing that autistic individuals show enhanced perceptual functioning, particularly in visual and auditory domains. Remember the first and second episodes of the sensory processing episode. This is heightened sensitivity to sensory details that allows a building of the rich, detailed catalogs, which are then formed and used to solve problems and make sense of the world. An example here is an autistic artist might catalog specific shapes or colors to create intricate designs. Remember Temple Grandin sharing her ability to design this cattle system, these livestock systems in her head, and she can work out the flaws in it in her head in real time. She sees this. This machine learning, these catalogs that we're building up, we're talking about, explaining, involves a process called iterative refinement. This is error correction. Remember the anterior cingulate cortex, part of the medial prefrontal cortex. Error detection and conflict monitoring. This is correcting things in real time. This is updating the catalog. This is machine learning and AI. Iterative refinement. This is so very fascinating here. So here is the perceptual learning in the context of the autistic phenotype. A definition here is experience-driven improvement in the brain's ability to process and interpret sensory information that results in enhanced accuracy, efficiency, and sensitivity to specific stimuli without requiring conscious effort or explicit instruction. This is a very unique skill here for the autistic phenotype. Remember what I explained earlier about that conflict and people not liking when things are outside of that box. This is perfectly acceptable for the autistic phenotype. We're just going to update. But keep in mind that black and white thinking here. Don't underestimate this. This process of perceptual learning is driven by neuroplasticity. And just pause for a moment and think about the social situations from way back into the critical period of infants and childs and babies. 1, 2, 3 years old and so forth. Remember that paper on salience network from UCLA? This is all connecting here. This is all in-depth exploration and understanding of the autistic phenotype here. With that perceptual learning, a key feature here, especially with the autistic phenotype and that detailed orientation of this cognitive style, describes an enhanced local processing. And this is accelerating and making us excel in certain tasks requiring precision that discriminates sensory detail. Examples here for the autistic phenotype may be subtle differences in the visual patterns, or auditory pitches, tactile textures, and so forth. Very fascinating how well autistics can do with these kind of slight nuanced. And also, keep in mind that sensory overstimulation. This is all a factor here. This is all in play. The example I've previously given about auditory sounds just blending together, and eventually they just remind me of a late 60s Beatles tracks whenever they're experimenting with different instruments and things around the studio that they're using to create sound. They're just blending all of these sounds together. It's typically at the end of the tracks. Maybe check out Sgt. Pepper's or White Album. Just listen to the complete track towards the end. Sounds just start to blend in real time for me in social settings. And they don't have to be loud sounds, just multiple sounds. This iterative refinement and the perceptual learning, this strong connections, similar to the associative learning, and that weak central coherence, the detailed precision of understanding things. It's a powerful mechanism for refining this sensory processing that kind of leads to unique implications for the autistic individuals. The accelerated learning ability and that sensory sensitivity, disability, and those restricted, fixated interests that are abnormal in intensity or focus. And now, whenever I say that the autistic phenotype has many contrasts to the social norms, including education, the school day, and within the classroom, you can hopefully see why. Start piecing this together about whether the autistic phenotype just prefers isolation and restricted interest. Those details and knowledge and the wisdom builds up and is very interesting to us, especially when you transpose these into real live movies in your head. So to end, let's do some similarities between AI, machine learning, and the autistic brain. Feature extraction and cataloging for the autistic brain. Grandin's visual thinking involves breaking down complex information into the specific detailed images, which she organizes into the mental catalogs. Her livestock shoot and working out those kinks and flaws, seeing the bottlenecks. Interestingly, people like Oliver Sacks, who just imagined being a bat, wondered and put himself into, I'm a bat right now for an hour or so. He would just spend an hour, 2 hours of his day pretending and imagining himself being a bat. And Temple Grandin did this as well with being a cow and kind of navigating the livestock chute. What areas would terrify me? What is the flaws here, the barriers here? What do they see? If you think about autism and the ability to be more docile, I hate to even use the word, but it's pretty accurate here, with the squeeze machine and the smaller classrooms and so forth, being in our preferred environment. This is what this is kind of doing here, having an ability to be something else, imagine things in great detail from different perspectives. In AI and machine learning, they have the convolutional neural networks. This is pretty similar to the autistic brain. Processes images similarly and extracts low-level features in different layers, just layers upon layers of the categories and catalogs. Both the autistic catalog and the AI feature extraction rely on bottom-up approaches. This is all very similar. Temple Grandin has a great example of AI for detecting melanoma. You just feed the AI machine, that machine learning, thousands upon thousands upon thousands of pictures of melanoma, and then you insert a subject, this new picture, and then it's just massively comparing it. It's just quickly comparing all of those images. And then this is sort of like the box example. If it fits, if the subject's picture fits the example of melanoma, accept. Detect it. If not, reject. So pattern recognition is huge here, and the associative learning. In autistic brains, associative learning allows us to form catalogs and connect specific visual memories. Remember the default mode network. Nuclei involved here is the hippocampus. And we have strong memory, episodic memory. It's very fascinating here, the episodic memory. For instance, the butterfly example. If you mention butterfly, Temple Grandin will remember a specific butterfly, maybe in her childhood, and where she was when she saw that specific butterfly. Specialized learning and connectivity. This is a big thing with the autistic phenotype. The specialized learning. And these hyperconnectivities of visual areas reaching out to specific detailed areas of other brain regions are kind of strengthening these connections, and those become preferred by the brain. The brain doesn't want to work, it just wants to respond based off of what it knows. We talk about neuroplasticity in quite detail throughout many different episodes. We are who we are because of these connections. With AI and machine learning, these neural networks in AI have dense local connections as well within layers that allows them to perform detailed analysis. Maybe it's an object recognition, or it's analyzing something, some sort of data. The autistic brain's connectivity pattern supports cataloging and specialized learning as well. Both of these systems kind of excel in domains where precision and pattern recognition are key. Accelerated learning, something that's very, very important. I cannot overstate Asperger's little professors, and even the children in the Canner paper. They had accelerated knowledge and information on just different things, random things in life. So what's so bad about that? In AI and machine learning, this accelerated learning uses that iterative approach. It's all doing the same thing. Transfers learning where AI applies knowledge across tasks and mirrors how autistic individuals builds catalogs for different categories. Both the autistic brain and this machine learning and AI accelerated learning builds by accessing detailed catalogs to precision. These visual images and the movies playing out are accessible to us in real time. If I'm explaining something, if I'm explaining the inner mitochondrial membrane and oxidative phosphorylation, I see that in my head. I see the 5 cytochromes and the FO head, and I can just reverse engineer that. I can just see it as I explain it. However, sometimes that delays my processing because I have to keep up with both, and that's an added factor. But I'll take that. I will happily take that because of this visual imaging and seeing movies in my head is very powerful. I have something exciting. I want to introduce a product unlike any other product available. A highlight is the product from Daylight Computer Company created their product based on these factors. The Daylight computer is completely blue light free. It has no flicker. Short wavelength flicker is extremely harmful for our eyes and downstream biology. Light flicker is constantly turning our central nervous system on and off. Essentially, it is like going to a light switch and repeatedly turning it on and off. The problem is, blue light and LED light does this, and it is so rapid you cannot even perceive this in real time. The daylight computer is the lowest stimulation and foremost for sensory sensitive users. It is no question that the alternative product, especially when used at night, do not address or consider this in their product. It is so toxic to human biology. Big tech corporations have patents on how their short wavelength implicate the human nervous system. And a bonus, despite daylight computer not having backlight, it is very functional for outdoor use. And of course, increased sunlight is always preferred. I am happy to offer a discount for the daylight computer. You can use the code AUTISM for a $50 off discount. Again, use the code AUTISM and the discount code for $50 off. See the link in the show notes to Daylight Computer Company, or just give it a quick search in your internet browser. Use the code AUTISM for $50 off. I would like to mention Chroma, lights designed for humans. Chroma, a Seattle-based innovator founded by ex-NASA and Air Force engineer Michael Shapiro, is on a mission to enhance physical and mental health with purpose-built devices, unlocking peak human health, cognitive function, and performance. Shapiro launched Chroma to restore the natural light lost to screens in indoor living and delivers faster recovery, sharper minds, and better sleep. Their products hit hard. The Iron Forge speeds muscle repair with red and near-infrared light, while the Skylight mimics sunlight to boost sleep and energy. A standout, the Forge lamp, is a portable gem that fires 660 nanometer and 850 nanometer light to energize mitochondria and heal tissues on the go. Remember the 4 red light chromophores on cytochrome C oxidase, frequently talked about in the podcast. This is why their products are built with military-grade durability that have lasting impact. Chroma's tech fuses precision and power. Gallium titride power supplies, smaller, cooler, and stronger than silicone, provide flicker-free light that's easy on the eyes. High-powered LEDs target key wavelengths for skin, tissue, and cellular health, with smart heat management for the lasting impact. Every design decision Chroma makes serves a purpose: to create devices that are precise, durable, and effective for improving human life. Remember, humans use different wavelengths of light for different functions of life. Remember when I ask, what do you think light is? Chroma designs with our biology in mind, from sleep aids and wound healing to mitochondrial energy, full body lights and blue light blocking glasses. They are US made and Chroma ships globally and accepts FSA and HSA payments. Use AUTISM at checkout for a 10% off discount. That's AUTISM at checkout for a 10% off discount. Don't ever underestimate the power of visual thinking and the autistic phenotype. This is very fascinating, very powerful. Don't interfere with this because you will harm the autistic phenotype. Embrace this. Allow them to embrace this. If you are listening to the podcast, listening to the episode, please feel free to leave a review or rating. In podcasting, reviews, ratings, and downloads are huge, and I very much appreciate your feedback. You can contact me on X at RPS47586. We can discuss anything and everything about autism. I very much appreciate your comments and your interactions on X. You can check out the YouTube page for all the videos, full-length videos, shorts, and clips. You can email me, info.fromthespectrum@gmail.com. Thank you for listening to From the Spectrum podcast.